In number 13, we're going to solve this equation by factoring. So we're going to factor this into w squared minus 2 times w squared plus 3 equals 0. And so using the product rule of 0, w squared minus 2 equals 0, or w squared plus 3 equals 0. Now, here we can rewrite this as w squared equals 2, and then use the square root principle, which gives us w equals plus or minus square root of 2. Similarly, for the second one, we can rewrite this as w squared equals negative 3, and so the square root principle tells us this is plus or minus the square root of negative 3, which is, of course, a purely imaginary number. It's plus or minus I square root of 3. So this equation actually has 4 solutions: negative rad 2, positive rad 2, negative I rad 3, and I rad 3. In number 14, we have to find the domain of this radical function, square root function. Because the index is even, the radicand, which is the inside part, has to be greater or equal to 0. Adding x on both sides, this gives us 3 is greater or equal to x, or, looking at it the other way, x is less or equal to 3. So in interval notation, the domain would be written as parentheses negative infinity comma 3 bracket. Alright, let's look at number 15. So here we have f of x equals log base 2 of x. Now of course we know that the inverse of logs is exponentials. The exponential of this has to have the same base, 2, to the x. And the next thing we need to do is to graph f and f inverse on the same coordinate axes. So here's the xy plane. And let's graph f first. Now you know that the domain of log is positive numbers. Okay, so we can make a table here of x and log base 2 of x. This is our f function. So when x is 1, when x is 2, when x is 4. So log of 1 base 2 is 0. Log of 2 base 2 is 1. Log of 2 of base 2 of 4 is 2. And so the points are 1, 0, 2, 1, and 4, 2. We could even pick a negative number like negative 1, or not a negative number, but a fractional number of half. We know that log of half to the base 2 is negative 1. So at half, we have negative 1 here. Now if I connect these points, then I have the graph of the logarithm, the original f function. Now the inverse function just reverses the x and y coordinates. So for example, for the point 1, 0, we have the point 0, 1, which is right here. For the point 2, 1, we have the point 1, 2, which is right here. For the point 4, 2, we have the point 2, 4, which is right here. 1, 2, 3, 4. It's actually right here. And then for the point half comma negative 1, we have negative 1 comma half, which is right here. And then connecting these points, we have the inverse function, f inverse of x, which is 2 to the x. Alternatively, we could have just made a table of x, 2 to the x, and just pick the values 0, 1, 2, and then negative half was the last one I chose. Or I'm sorry, negative 1. And then 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the negative 1 is negative, or is positive half. And we could have plugged in those values and just switched x and y to get the graph of log. So here's f of x equals log base 2 of x. And the green one is the graph of f inverse. Now, one thing to check is that there is a symmetry over the line y equals x. So if you reflect the green graph over the blue graph, they overlap perfectly. In number 15, we have to calculate the quotient f over g of negative 2. That's very easy. That's just f of negative 2 over g of negative 2. So if I plug in negative 2 inside f, I get 3 times negative 2 squared minus 4 times negative 2 minus 1 all over, plug in negative 2 inside g, 2 times negative 2 plus 1, and then work these things out. This is 12 plus 8 minus 1, and this is negative 4 plus 1. So this gives us 19 over negative 3. So the answer to this question is negative 19 over 3. For part B, we have to build a composite function. F composed with g is f of g of x. So inside here, I put g of x, which is 2x plus 1. And then, to perform f on it, we're just going to copy the definition for f with blanks. 3 times blank squared minus 4 times blank minus 1. And inside these blanks, I'm going to put the input, which is 2x plus 1. And then simplify. So this would be 3 times 4x squared plus 4x plus 1 minus 4x, or I'm sorry, distribute, minus 8x minus 4 minus 1. So we get 12x squared plus 12x plus 3 minus 8x minus 5. And combine like terms here, we get 12x squared minus or plus 4x minus 2, and that's the final answer.